Okay, so here we're going to look at a basic electric circuit. And so through reading the theory, we've learned a little bit about what we need. So first we need a voltage source, right? So that could be a variety. It could be electromagnetic, it could be piezoelectric. In this case, we have electrochemical, right? So we have an anode and a cathode. Cats have pos, so positive is the cathode, and we have the anode. So we have these different charged ions inside this battery. So the negative has a whole bunch of extra electrons. Okay, the positive is missing electrons. Okay, and we know that everything wants to go to a balanced state. So the negative wants to give up all these electrons, and the positive wants to collect them all. But they can't inside the battery because it's insulated in between. Okay, insulated by an insulator. Something that has more than 4 valence electrons, where the electrons can't, they're held on so tight inside of each atom that they can't break free, so they can't move, okay, as opposed to a conductor. So just as battery sitting here right now has potential voltage, but nothing's moving, okay? So then we need conductors. So we need something that has less than 4 valence electrons. So this copper wire has 1 valence electron, and so we've got the nucleus with our protons that are positive that's attracting these electrons, but they kind of work together. So if there's only one, it can't hold on as tight as if there's more than 4. So we got one little valence electron, the outermost electron, and it's kind of hanging on there a little bit. If I apply a force to it, even though it's attracted to that positive, it just it can leave, right? So much so that you may have even read about free electrons, where they just kind of break off and then go to a different atom and just kind of float around without direction. So that's what we're going to be doing. We're going to be moving electrons. So we have to have a conductor that allows them to move. Okay? We have to have the insulator in here to not allow them to move across from here. Okay? So we're going to hook up this circuit. Okay? So we've got our conductor here. We're going to hook it up to the negative side, and we'll hook this conductor here up to the positive side. Hopefully we can open that wide enough. Usually I've got an RV battery with that extra little terminal, but there, we got her on. Okay. So, what is happening here? Well, we have a difference of charge in the battery. We have the negative with extra electrons. We have the positive that's missing electrons. Okay? So, it's not really, we say a complete path for electrons to flow, and I used to think that that meant a complete circle, and they just kept going around, but that's not the case, okay? All these extra electrons are leaving here and collecting over here, and they'll do that until this is balanced, and this gets the same amount of electrons as here, and then they stop moving, okay? So yes, it's a complete path up to here, but not across, and they don't just keep perpetually going. So we have electrons right now leaving here, moving through here, so each atom in here, each valence electron is jumping from this one to this one to this one to this one, and all these electrons are moving through here, through this connection, and through here into 3 different branches. So if you've done some reading, you should know that this is what we would call a parallel circuit. So each one of these branches has the full 12 volt difference between the positive and negative side. So electrons are going through here with the full 12 volt difference. There's 12 volts of difference moving electrons through here, and 12 volts of difference moving them through here. Again, electrons coming through here and collecting onto here. So that's what's happening. That's how this is working. Now, if I disconnected this, okay, and I just connected this up here like this, okay, we get a spark. If I held them there, this whole thing would start to burn and melt and should be smoke everywhere. Okay, it would be pretty cool, but it would be really smelly, so I don't want to do it. But what's happening in that situation is we still have a complete path. If I close those together, and you saw that spark, current will flow through here and come back to here. Electrons will be moving, but they're going so fast that it's creating friction. That friction's creating heat. That heat's melting the wire. Okay? So that's why we need that third part of the circuit. We need the load. We need something that can slow down those electrons. Okay? So if we hook it back up like this, we have this load in here, so the electrons are moving through here, but now they're getting slowed down by each one of these bulbs. So the bulb is a special tungsten filament that can handle the heat. and that slows the electrons down, but it also gets red hot and creates light, and that's what we're seeing, right? We're seeing that heat light, okay? And there's various loads that can slow it down. An electric motor slows it down by counter electromotive force. We have resistors that slow down electrons. So as long as we have some sort of a load in there, we can slow the electrons down enough that they don't melt and burn our wires. Now, different loads, of course, take different amounts of current to operate. So the higher the resistance in the load, the more it opposes the electrons, so the lower the current goes. Current is that flow of electrons. Okay? The less resistance there is in a load, the more current it lets through, and the more electrons it lets through, so that current is higher. Okay? And so then our system needs to be rated for whatever type of current the load draws. Okay? And we can measure that and get into the math with some of the booklet work, which we won't do in this lesson. But what we will talk about is gauge of wire. So we want to make sure that the wire is thick enough to handle the current that's flowing through here. Okay? So this wire looks like about a 14 gauge. You can see that it is much smaller in diameter than this wire. Okay? So this wire can handle a lot more current without getting hot and melting than this wire could. Okay? This looks like about 8 gauge wire, maybe 10. Okay? So it can handle a lot more current. The higher the number, the thicker the wire. Okay? Until we get to 0, and then we call it aught. And then we would go to 1 aught, 2 aught, 3 aught, and we just keep adding zeros. And that's what we're talking about, like the battery cable wire. That's usually like around a 2 aught wire. Okay? So that is a basic electric circuit.